everyone. Few of our basic settings here. So let's go back. Thank you all for joining me. I know that this is a little different from what you're used to. So let's for a second. If you're joining me from the United States, I would like to thank you. I know that, things are very different out there. People are celebrating the 4th of July, and today is one of those different days. So really appreciate everybody joining. Hey, Mark, thanks for letting me know about the music. I think we just turned it off, and hopefully you can hear me. If you can't, please let me know. But welcome to IT Security Labs, and today we have yet another live stream where we are actually going to be looking at a very popular privilege escalation attack. We're going to enumerate a Linux server, identify a vulnerability, break into it, then do some privilege escalation. And during that privilege escalation, we'll learn about a very popular privilege escalation technique that was identified. I'm going to show you how the detection happens. We'll go through the rule that we set up to make sure that everything is set up correctly. Then we'll detect that rule, and then we'll learn about, the wazuh agent and the rules that we have. So thank you all for joining, and I really appreciate it. The main goal really is to end up knowing how to do a proper enumeration on a system, how to properly attack a system, and most importantly, how to actually detect those attacks. So that's really what we're here for tonight. And if you are brand new to my channel, my name is Howard Mukanda, and I hold a few certifications in IT. Most of what I know is from being self-taught. So I'm very, very passionate about teaching myself every week something new. And I happen to want to share with you every time I learn something. But I did get a CISSP, an OSCP, the CH, even a few weeks ago, got the CCNA. I'm just out there learning new things. But my career in cybersecurity started at help desk. So I started answering phone calls with people telling me that they could not work on their Excel spreadsheets. I did network administration, and right now I work in cybersecurity. This is our network diagram. For those who might want to follow along and know how things are set up, we have a Kali Linux machine. And my Kali Linux machine here is going through a Unify switch. It's a layer 3 switch. I'm doing port mirroring here on this switch to a security onion intrusion detection system. So that's the fun part here, is we can see everything that's coming from this machine going to a Windows 10 machine that we are attacking that is hosting a vulnerable machine. So if you are not familiar with this type of attacks, this is what happens in the real world, where network administrators would, or network security people would like to see everything. Most of the time they will use a port mirroring feature, like, a better solution than a layer 3 switch. But for our lab, it works. Network taps are very popular here, but in this case, we're using that. So in addition to this, we are also sending our traffic using a tool called a wazuh agent. And wazuh agent allows us to view traffic from the host, doing host-based intrusion detection. And that has been my favorite thing over the past few months. So as you can see, going back to my security onion, I can refresh this in the last hour. I can see I was just doing a quick test here to make sure that this is working. We are getting events here. It doesn't get any fun than this. If you can do this at your house, I guarantee you that you can show up in an interview and blow their minds off, because they'll be like, you can actually detect events in your own home lab. That means that you can be trained to view their events at work. To me, this is gold for those who want to study cybersecurity. But without wasting a lot of time here, let's jump into our lab environment and start attacking. I have my Kali Linux. It's just running right here. Let's go back here. And my victim machine was on 192.168.38.128. So I like to start with a ping make sure that this thing is responding, because sometimes they crash. As you can see, it's responding. Our first phase of attack here is enumeration. I kind of cheated a little bit here because I already know my IP address, which in some cases, if it's a pen test, they would have given you the IP address anyway. So nmap-sv -sc 192.168.38.128. So we're just running an nmap on the top 1,000 ports of our victim. We're saying, hey, can we see what is running on the top 1,000 ports? This does not mean port 1 to 1,000. This means the common ports that are TCP ports. If you want to be comprehensive, you should put a -p at the end here to scan all TCP ports. Then you should also start another one to start a UDP port with a -su. But for CTF, this works just fine for us. While this is running, let me come back to the live stream chat. Nav said he wants to see the rules that we're working with on Security Onion. Yes, you will definitely see those rules. Today, we're not looking at suricata rules. We're looking more on the wazuh rules, but I'll show you where those rules reside. In fact, the rules that are firing today, I had to go and add them myself, which is a very good skill to have. So I'll show you where you can go and add some rules here, which is awesome. BT, thanks, brother, for joining. Are you inspecting SSL traffic too? No. I would need an SSL decryptor for that. And in this case, no, I'm not viewing any of the SSL traffic. But it's something that in the future, hopefully, we can learn how to have a cheap SSL decryptor. All the ones that I've seen so far, they cost thousands of dollars. Today, we are more focused on endpoint detection. So mostly the wazuh agent, host-based intrusion, also some network intrusion. For example, right now, we are running nmap. Let's see if we can actually just see a bunch of chatter from nmap here. Nmap usually gets caught in our lab because, it's nmap. Nmap is noisy, it's clumsy, it's one of the clumsiest ways of trying to enumerate a network. And every week I always say, if you're going to enumerate using nmap the way we do it on this channel, just know that this is by far the clumsiest way of joining someone's network. Look at this. We already generated a bunch of traffic here. All these, you will get caught by the default suricata rules in this case. These ET scans, they're all from nmap, just running a bunch of things, which in this case, it's okay for us for learning. For a pen test where you're trying to hide from defenders, I would maybe shy away from using nmap. I'll write my own custom bash script to do a port scan that doesn't send an nmap user agent, for example. This one here is what we'll be talking about at the end. This is the actual rule that we have. I was testing it before we started. This is not from nmap, but everything else that you see here is from nmap, except for this one and this, the very top one. We'll be covering those in a little bit. But yeah, so let's go back and see. All right, so our nmap scan is taking forever. I know why this is taking forever. It's because I'm also running a WP scan here. I'll let both of them run. All right, there we go. Right on the money. As you can see here, on the top 1,000 ports, we found the two most common ports, 22 and 80. And in this case, it also identified that we're running in VirtualBox, which is exactly what we are. If you want this machine that we are running on, if you go to the description of the video, there's a link that allows you to download the same exact machine. Just import in VirtualBox, bridged network, and you can attack it the way I'm doing. All right, so port 22, we got it. And then port 80. But before we do that, I'm very excited about this one right here. Mike said you should do a VV after Nmap to just see this in real time. Yes, that's Mark. I've been saying Mike all this time. Yeah, thank you. Then minus T5, I think T5 speeds it faster, and I've seen where if I use T5, then I lose the accuracy of my scans. So I avoid the T5. Sometimes I use minus T4, but yeah, that also works. Then what about the lab requirements? Set up this lab like this. I'll cover those ones at the end. I'll show you what my VMware setup looks like. It's not that bad. It's just one Dell server that you can get for like, $300 from eBay. It's really not that bad. And yes, I do use Python. Python is by far my go-to scripting language. All right, so we have port 80. What is the logical thing to do after you identify that port 80 is running? You go and visit that site. So if I go here, I'm getting a little lag here. This is from this command that I'm running here. I'll show you in a second what that is. But let's open a new tab and come back and view what we have here. All right, so before we go and visit the site, I just wanted to let you know this is right here. This is the alerts interface for Security Onion. This little bell here allows us to acknowledge the alert. That means that it has been acknowledged by someone, so you can actually do real-time response in here. This little exclamation mark here allows us to escalate this alert, maybe to level 2 or those who are more experienced than us. So if I wanted to acknowledge this, I'll just click the bell. It will acknowledge the alert. Now it's in the acknowledged tab. That means that someone has seen that. If I wanted to escalate an alert, I might be able to do something like this. Escalate to a new case. This will create a new case and escalate the alert. That way, someone else will be able to see it out there other than myself. But for now, we just want to keep all the alerts here. If you want to interact with these, which is a very fun thing to do, by the way. So if you're looking at this, you're like, what in the world am I looking at? Why do I need that? The goal is a lot of employers, regardless of what SIEM solution they use, they have the same thing. Data looks the same. They will have alerts. They might not look like this. They might look fancy with color-coded or whatever they look like. Everything is the same. It's an alert. You have a count of how many times you've seen that alert. You have to acknowledge it somehow so that someone does not pick it up, but you have to assign it to yourself. You can drill down and see what's actually happening on that alert. In this case, we had 3 instances from Nmap, by the way. You can expand. This data here does not change. It doesn't matter whether they put this information left, right, center, format it, color code it, make it green, purple, blue. It's the same. You need a timestamp for every event. When you go to a SOC environment, this timestamp has to be as accurate as possible, so it doesn't really matter. If you have a setup like this and you know the significance of a timestamp, you know that this timestamp could be in whatever time zone they have standardized in that environment. It makes sense. Destination IP, they might not call it destination.ip. They might call it DSP IP, whatever they call it. This is where the traffic was going. This event was coming from the network. It's an alert. It was detected by suricata. So in this case, we call it event.mojo, but if they call it event source, who cares? It's coming from a suricata. It's a suricata event. That means that we saw traffic on the network. It's a suricata event. For the severity of 2, which is a medium, in this case, So this is not a custom rule. This is a default suricata rule. And then, of course, you can read more about the rule that we fired right here, which you might almost have to understand. Like, okay, what was the rule? What is it actually doing? In this case, it's in emerging threats rule. Let's look at this rule for a second. If you don't know how to actually read these rules, they are very easy. They're like 10 times easier than you'd think. We want it to be an alert. That's how we define it. It's looking for TCP traffic. The $home here is a variable that defines most of the time home or local networks. So they're going to be like your 10 networks, or your 172.16 to 32 network, or 192.168 networks. That's the default ones here. The private networks that you see to any, then of course going to external net on port 22. In this case though, external net is still internal, but that's just how this is defined here. And the message that we want to print, you can put whatever you want here. So this message here does not tell you anything. It's just whatever the person who was creating this rule wanted to put here. What's interesting is after that, we're talking about flows to server. We're looking for TCP flags. A flag of S with 12. Then we have a threshold here. And let's see. We're referencing Wikipedia for a brute force attack. Really? Okay. I'll take this one. I find this one to be actually a little comical that we're going to Wikipedia, because I can go to Wikipedia and edit the page right now if I wanted to. But this one, of course, is going to the same location. So this link here is the same link here. So if you ingest this rule, you get this link, which is how we got here from Security Onion. So that's just how suricata does things. Someone had mentioned, hey, let's go through a suricata rule. That's an example of that, where we saw port 22. It thinks that we're being brute force on port 22, which, in this case, we're using nmap. Yeah, we are trying to brute force. This is not why we are here today, though. We're here to make sure that we can detect privilege escalation. So let's go back to our Kali and finish that job first. All right. I'm going to stop this scan here. It's taking forever. All right, so where did we end? We ended where we said we can go and visit the IP address, which is this one. Since I stopped a scan, it took 30 minutes last time when I was practicing. So yeah, I'm not surprised it's still going right now. You can go and visit the site, which in this case, let's do it outside of Kali. So it's a hello world. I don't know about you, but I've seen so many of these sites to the point where by just looking at this, I'm like, yeah, that looks like a WordPress site to me, even before I scrolled all the way down. If I move myself out, if I can, it says powered by WordPress at the bottom here. So what does this mean? This means that we have to summon WP scan. We have to scan this thing using a tool called WP scan. It's a WordPress site. Another thing that you can do, of course, is just click around and see. The first thing that I look for is who is writing these blogs. If it's a WordPress site, does it say like, S Smith? That means that I now have a username by default. Does it say who is actually running these scans? In this case, it doesn't actually say anything. It takes me to Beloved. So I would go to my Etsy host and add this entry here. It says Beloved. So you need to go to your Etsy host, put the IP address of the site, and the name beloved. How did I not do that? I just visited the site and it says it right here, beloved, and that's the name there. Okay. There's a wp-admin. No, is it login? Yeah, there's login and admin that you can always try. So this one does have a WP admin page. Why would we be interested in this login page? Well, we are attackers. This is how we get in. We want to know, can we try to sign in here? So admin would do. You know, you can try our SQL injection. You can try any of the SQL payloads that you might have. In this case, I have a ton of them. Let's try this one. I don't know why, but a lot of WordPress does not have SQL injections. It's almost like a waste of time if you do this, but it's not, you know, I'm not beneath that. I would use maybe Burp Suite to try to send some SQL injections to this page. In this case, you're not going to find anything here. Better off to move on to the tool that is created for WordPress, and it's called WP Scan. I've done WP Scan on this channel, and I've also done it through my CH studies. So let me show you some of my notes from my Certified Ethical Hacker training. Okay. So I have a link where I usually use this one just if I like forgot about WP Scan and I'm like, oh, what is that thing again? And here are some of the examples of, you know, enumerating for things. And it says good article here, so this must be good. I put it there, so it must be good, right? So here's an article that will explain about WP Scan. I'll put this in the chat for those who are writing their own notes. I've already done the work here. I'm not going to do the work again of Googling or searching. But in this case, it will be like, hey, here's how you use WP Scan. And you can use roq.txt to brute force WP Scan. And all these are the examples. One thing that I don't like is that they actually don't have like, it's not like code that I can see the distinctions. So because of that, that one is out. Let's go to the hacking article one. This should be a lesson for yourself and myself that, you know, if you do something once and it's documented, so we can use WP Scan for help. I like this one better. And it looks similar to this, which is good. We can scan the site. In this case, we are going to /WordPress. This is where script kiddies might be filtered out. Our WordPress is running on the root directory of the site. So we're not going to /WordPress. We're just going to go like that. You can enumerate themes. We're not doing that. You can enumerate plugins, which I'm going to do. So let's just use that. We're not going to use /WordPress because our site is running on the root directory, but it's on 38.128. Or it's just called beloved. So maybe we can, it doesn't really matter. If you use this scan here, it might not work. So you have to do --aggressive. There's a couple switches you can take here. Let me make sure that I have the full switch. Was the first time I ran this, it didn't find any themes, then it did. If you use the WPScan API, it will find the themes for you. But if you don't use the API, it might not find the themes for you. So let me make sure that I'm actually doing that. Okay, then let me put threads here. Can I put 500? Maybe this is what will crash my Kali. But this is how many concurrent threads it will try to run on my system. But I'm going to scan for plugins on this site. Let's find out. If it takes forever, you don't have to worry about it because I already ran it and I left. Dash aggressive. If I can spell, that will help. Dash aggressive. Why is it not taking my okay, let's specify it in full terms. I thought EP would work, but it wants plugins detection. We'll give it the full plugins detection words here. Still doesn't like the okay. I didn't have to say dash aggressive. No, I do not want to update my WP scan. I like the old version that I have. So this is going to scan the WordPress site. If you're like here and you're like, hey, what just happened there? Let's take a step back. If you go to a site and you're doing a test and it says, hey, we are running WordPress, and you try the login page that we tried here and you don't get anywhere, the next logical thing to do is to run a tool called WP Scan. WP Scan is a WordPress scanner. You will see that a lot of frameworks like WordPress, there's other ones that you see up there. So if it's running other tools, other default tools, you can go and run them. In this case, it's running WordPress. We tried SQL injections. It's not working. You can even try to go to things like, robots.txt and see if it works. In this case, I will be damned. It's actually there. I was just doing this. I was like, hey, I will show you how to do this. And here it is, WP admin. This file here is actually showing you what the robots should not crawl. That's like Google and all those sites that automatically index pages. This is an interesting one. I'm going to check both of them. Let's view page source. The idea here is if you say robots should not see these pages, me as an attacker, I would like to see those pages. Well, WP admin, we get it. There's a login page there. And here's the sitemap, just in case we're interested. I don't think the sitemap is going to show us anything more interesting. But of course, with the post, I'm not interested in those. Sitemap users.xml, that's interesting. I think we're getting trolled. We'll find out either way. So this is the author that we have for this page. Okay. All right, that didn't lead anywhere. So this is how you can interact with a site and just be able to see what you're looking at. In this case, we're running WP scan, and we were scanning before it crashed. What happened here? I didn't like something. So it looks like it ran, then it started complaining about something. Okay. Let me just look at the results before I start wondering why it crashed. Aggressive scan. All right. Anyway, if you run WP scan, I really don't want to fix this error here. But if you run WP scan, I want to show you what it looks like on the detection side. I think you have to know, before you go out there and start running a random tools from the internet, you got to ask yourself, what does this look like on the network? What does this look like for a company? How much traffic am I generating? Am I causing too much traffic? Am I not generating any traffic? You actually, without being too harsh, if someone was in my network and I hired them to do whatever, pen test, red team, whatever they call it, if they showed up to my house or my company and they were running WP scan, and I said, oh, so what does WP scan do? And they're like, oh, I have no idea. So you're telling me you found a tool from the internet and you're running it in my network and you have no idea what it's doing. You have no idea how much traffic it's generating. You have no idea whether or not it's going to crash my system. You and I can agree that that's a problem. That's a very, very big problem from people who might call themselves pen testers or red teamers to show up to your company, to your house and say, oh yeah, I just ran WP scan. You ask, oh, so how many threads did you use? How much traffic did WP scan generate? They have no idea. You have to know. If you're going to use WP scan with a default word list like this, in this case, I generated 28,838 stuff, events as you call them. What do they look like? This is how much noise you are generating if you choose to run WP scan in someone's environment. And I think that's important, and I think it's fair. The last thing that I want is somebody who doesn't know how much noise, how much ruckus they're causing in my network they're doing, and they're just running some tool from the internet, and they have no idea not only what the tool is doing, but what the tool can potentially do. So if you run WP scan, you get a bunch of 400 errors from the site that you're running it against. That's significant because you can cause a denial of service for a customer or a client if you're not careful. Here's a bunch of them. Let's pick on one. And in this case, the agent IP was, 128. That's the one we're going for. Beloved, these alerts are coming from the server that you were running WP scan on. This is not coming from the network. This is coming from the actual victim that you were running WP scan against. The victim is saying, I saw 28,000 times where you were trying to access stuff on me. And in this case, this is going to be logged in the access.log. So if your client has any form of detection, you fire up WP scan on their network, access.log, this file here is going to get big and bigger and bigger and bigger with entries from you. And I think that this is what distinguishes, what we do on this channel with everything that you've seen on YouTube about detection or CTFs. Because we mentioned this, you have to be aware. This file here can get big, especially if you're using default word lists like roq.txt. Whatever brute forcing you're doing can cause this file to get big. They will detect you right away. You might cause a denial of service on this victim here. In this case, what are we doing? Why are we actually getting these entries? Look, you sent a head request here to just the plugins. You were looking for a plugin called Add Blomatics. This is the brute force here. We sent WP Scan. We said, hey, WP Scan, here's a list of all known WordPress plugins. Can you go and check if they exist? Who knows how many plugins are on this word list? There might be a million of them. That's why this thing takes 30 minutes. And during that time, access.log is getting a bunch of 400 errors. It's logging every single entry. If you don't learn an appreciation of the impact of this, you might find yourself with customers who might understand what you're doing, who might discredit you. Like, to be honest, if a pen tester didn't know that this is what's happening, I would wonder, what other tools are they running on my environment and they don't know what they're doing? That's just another question to have. But you get a bunch of 400 errors from the customer because you're brute forcing for plugins. Is this the best way to do things? No, but is this something that you might do? Yeah, just be aware that that's what's happening there. And you're causing a lot of stress on the system, and you're also growing a log file that you might want to suggest maybe to delete later, just in case it's too big. So that was the first one from just that WP scan command that we ran. And remember, that was just us scanning for plugins. If you run the default WP scan, it will scan for users, then it will go and scan for plugins, then it will scan for everything. So if you leave it running for 4 hours, because you're like, well, I'm scanning a customer, what's the worst that can happen? The worst that can happen is they'll get a bunch of logs, and if they're detecting you, they'll block you. If they have any detection in place, they might rate limit you. So just be aware of what we just covered there. All right. That's really not what we're here for. We are here after a plugin. So I'll leave WP scan alone. If you run this one for around 30 minutes, you identify a plugin, and this plugin is called, trust me, it's actually there, WP Discars. I'll show you what Sagesploit says about that plugin. So this plugin here is what you identify from the last command that I ran. It will take 30 minutes. If you want, and if you're following along, you'll probably see it after a while. But this is a plugin that's running on that system. It does have a remote code execution. It's unauthenticated. So this one, of course, is going to be a high severity alert if you get it. We also have a Metasploit module here. During learning like what we're doing right now, I tried by all means to avoid Metasploit. This is probably the easiest way to do it. We're not doing it that way. We're going to go through this one. So let's go to our machines, beloved. If you want to copy this right here, all you need to do is just say Sagesploit. I don't think you need to give it the full path, but it's -m. -m. Then give it this path here, which is, you know what? Let me just give it the name. Let's see if it works. That's the one. You might be curious. I had 3 options there. I chose Python. Why Python? Well, because I like Python. In this case, it says the path. Well, I already have one. Yes. Let's override that. So now I just copied a copy of that exploit. I like Python. I can read Python better. There was a Ruby. There was a Bash script. Maybe a Bash script would have done me better, because actually I'm better at Bash than Python. But right now we have a Python script. All right. So on this, if I do a, let's name it something fun. I'm naming it this because it's easier to remember. Nano. I'm using Nano to make sure that it's easier for us to see, but it'll be a disservice for us to go out there and run a script without knowing what it's doing. So why not go through the script with Nano? So it was written by this author here, Felipe Oliveira, and there's a link to their stuff. This is a plugin that you identify if you do a proper WP scan for 30 minutes. It is an assigned CVE. That means that you can find this on ExploitDB, most likely. Importantly, it's using Python 3, so you gotta respect that. It's using these modules here. So one thing that you might notice is your Kali might not have one of these modules. In this case, mine does have all these modules loaded. If it doesn't, just go ahead and import a module for Python 3. It's not the end of the world. But it takes these parameters here, -u for URL, action store, the destination URL, and here's a help that you can see. All right, so let's do a quick check here. So if it doesn't have the URL, it will print an example to the user. Okay. And it will do a replace for WordPress. In this case, we actually don't have a /WordPress, so this is good for us. It will print a banner that says, hey, we're doing remote code execution on WordPress. Okay. Yeah. So let me see where they're actually generating a web shell. They passed it. So it's saying it's sending a get HTML, which I think we defined somewhere up here. Define the name random. So we'll get a random URL name here that they'll print out, say, hey, your reverse shell is right here. They're using this admin.ajax.php. Remember this one, we saw it in that robots.txt file. Okay. Then they'll upload a custom web shell for us, so we don't have to generate anything here. Okay, let's do a Python 3. Exploit.py. Let's specify the site that we have. In this case, I think it is said -URL. That was beloved. Let me see if this one will run. There we go. So the path was a 2021 blog post. So I don't have a /WordPress, so I'm going to use this. If you didn't know that, you'll be in a lot of trouble. There's P. We're running our site on the root directory, so that should work. Hey, and thank you, Matthew, for suggesting the different options. And please don't do anything, that will land you in jail. Okay. Let's see. Python 3 exploit URL build out line 23. I'll just change this to 7. See if I get a new link. Give me 1 second. Let me find out what I can change here. Maybe that. The site said hello world. Okay, so if you're like, hey, what were you doing there? I was just trying to do, they had a blog post as a default one. Well, my site had a default hello world on it. So I was just trying a few things. And looks like hello world worked for us with the exploit. This is how they filter people who don't know what they're doing to people who might be able to, read the exploits and be able to understand. So this one was like, hey, we only take, if you give us a path. At first it did /WordPress. Well, we are not there. We're running our site on the root directory. So we didn't need that. Then it said, oh, we take this date here. And then it gave us a default name. And I was like, wow, it's not working. What the hell? Then I put hello-world, which is a page that exists, and said we successfully uploaded a shell. So let's open this. Let me copy link selection as well, just in case. This browser seems to be locked into some limbo or something. I might have to restart the browser. Come on. Let me open a new one, just in case. You know what? Forget that browser. We have another browser here. There we go. Who knew that opening a link might be this interesting? So this is our location of our reverse shell. This is the random string that it generated for us. And then it is a .php and quote. It will contain something like this. But if we remove this and quote here, put a question mark and say cmd equals ID. Now we have remote code execution. And you can read about the plugin execution. There's a whole blog post about it somewhere on the internet. But if I can run ID, I should be able to get a reverse shell here. Let me know in the comment what your go-to reverse shell is. But I have a browser that can give me remote code command execution as www.data. The one thing that I looked right away when I typed the command ID was, am I in a container? Most of the time you'll be able to tell because there'll be a container group here. In this case, we're just in as www.data. Before I go and get my reverse shell here that works, let me know if you ever get to this point, what's your go-to reverse shell? Remember, we have Python 3 that we are using. We should be able to get a reverse shell and be able to run commands on this system. While we are doing that, let me check our alerts. Just close these. How much noise did we generate here? throughout all those trials and tribulations that we just went through. Okay, other than the 400 errors here, we got caught by this CMS as well. So, I like this one better. It kind of say like it's Joomla or WordPress. It should just find that it's WordPress. This is not a Joom scan, so I'm interested in this one. What did we see here? Okay, it's just the WP admin. It's web attack, of course. Look, there's a HIPAA rule. That's an interesting one. All right, so we did get some alerts from all that little noise that we're getting there. But let's go back. Great, we know we have an command injection here. I was hoping that people can let me know what they usually do to get reverse shell. But this is what I do. When I can put commands in a browser, I have two options. I can send this to Burp Suite, intercept the request, and start messing with it. Or I just go straight to this wonderful site here and generate a payload for myself. This is the revshellsonline.com. It's in the chat for those who are writing notes. First, I put my IP address. I'm like, hey, this is my IP address, 192.168.38.34. How do you find out the IP? This is the IP address of my Kali Linux. IPA. And sure enough, that's the IP address. This is where you want your reverse shell to be sent back to. I'm also running Docker for some other stuff. The port, let's change it to a nice number. 666 sounds like a good number to me. It's not 360, so I think I'm good. Then I say, hey, for the operating system, I'm going after Linux. I would like Python 3 because my system is running Python 3. Kind of important here. How would I know that my system is running Python 3? I can ask it. And by the way, Python is the easiest reverse shell that you can get. So which Python? To look for Python 2. I also have Python 2. I don't know why I'm bothering with Python 3. Okay, so we do have Python 2, which Python 3, and we also have Python 3. So let's do it that way. Let's choose Python 3, but we have Python 2. Most cases, if it's a modern system, Python 2 is going to be deprecated. It won't be there. So why not just go with Python 2? I mean Python 3. So Python 3, my IP address here, it says, oh, run this. Oh, I will do that. If this doesn't work, know that you have to URL encode stuff. This is where I'll jump to Burp Suite. If the browser doesn't work directly, URL encoding seems to fix a lot of my problems. So just know that it's not worth to just jump to URL encoding, but in this case, my command starts right here. So I put 666 naked minus LV and P. I need to put my 666, not 666, quadruple 6. All right. Now come back here, hit enter. I see the spinning all the way here. That is gold to me. That means that my reverse shell worked. If it fails right away, I know it didn't work. So for starters here, I'm in as www data like anticipated. Since I use Python 3, I need to stabilize this shell using Python 3. In my rev shells, I have both Python 2 and Python 3. For Python 3, you just have to import Python 3 and export term. This is just how you have a nicer shell. This will not make anything easier than your ability to navigate the screen. Like exporting term just makes it into a nicer shell. You can do more here. I choose to just stay here because I'm able to do a lot of what I can do from here. But before I leave this directory, I like to check what's in there. Okay, there isn't anything. Let's go to my uploads. Nothing there. So I'll keep going down. 2021. Maybe I'll check the other one, but for now, I'm looking for anything that doesn't look interesting. So uploads is fine. Plugins, I already scanned those. Themes, upgrade, index.php. Nah, that's okay. Here I would like to maybe cat the wp-config.php. Here you can see some passwords for the database. If there is any MySQL database that's defined, this is where you can see. For example, here's an auth key. This is a big finding, of course. Now you can start looting. So you are looting from this site. Just showing you what's in here. So just have the default WordPress DB. Look what we found here. The password to the database. So if there was a MySQL database that's exposed, this is where you go. You get this username and password. The username being WordPress user, and the password being secure password 2021. You use this password to sign into the local database. So since the database was not exposed, I'm assuming it's running on localhost. So you can actually go and try that. You can also try password reuse. If you found some users on this website in this password, you can brute force and see who reused this password. As you can see, our database is running on localhost. If we get desperate, we'll come and sign into the database and dump all the passwords. But for now, we'll move on because we know that this is not the way in, at least for now. All right, so we found some password, cd. We don't have home defined, so we just go to home, ls. We have a user defined, beloved. Okay, we can't get into beloved's location. This is good practice. Sometimes we can, so the thing that we can't, that's good. There are two ways to get privilege escalation on this system. I'm choosing the one that fits my narrative, so I can kind of control this. I want to show you a privilege technique using PwnKit. How do you identify PwnKit? Maybe we should start there. cd/tmp. All right. So we're going to run linps on this thing. So on your Kali, if you do a locate linps.sh, you have linps somewhere. So I have mine here. Do I copy? Maybe I should just go there and just host it. I have to move linps to my victim. So I use Python 3 -m http.server on port 80. The module. So the file that I want to download is called linps.sh. I also have polkit exploit in there. Probably from one of my machines. So let's download this to our victim machine. in the temp directory, wget http, come on, 192.168.38.34 and linpiece.sh. I think that was what it was. Let's make it into an executable. All right, and once it's done, let's run linpiece.sh here. It's already an executable, as you can see. I like the results to go to privs.txt. So this will take a while. Linpiece is going to scan my system for potential privilege escalation. The interesting thing here is that you can go through this file and identify all kinds of possibilities for privilege escalation. And immediately I'm regretting my decision here. I should have sent the errors to dev now, but I didn't. So we're just gonna deal with these errors. There are not a lot of them. But for the sake of time, let me show you what that file looks like. Come on. All right, so it won't show me as root. I need to be the user www data. Oh, wait a second. It's finished. Never mind. So we ran linpiece. Before I look at the file, what did it do? How much noise did I generate from just running linpiece? So this is the state before last time. We should see a lot of wazuh agent alerts. Or at least they should be. They actually aren't. Let's try one more time. So if you want things to be more interesting, you should run a tool called audit D. Yeah, so running linpiece in our environment here did not generate a lot of events. By the end of this live stream, I'll show you there's a auditing tool, a local auditing tool that we should run. Before we do that, let's also run just a quick check for SUIDs. So in my privilege escalation for SUIDs or SUIDs, do I have any SUIDs for WW data? I do not think that any of these will be interesting, but hey, look at this. With a polkit agent helper here, which also points us to the polkit privilege escalation, by the way. This is how I was able to be like, yeah, that looks like the polkit. We have a helper. And I was like, maybe I should just try that. Everything else here looks interesting. I had to Google this one because I wasn't familiar with it, but everything else, you can tell that looks normal. Anyway, let's look at our results from privs.txt. So let's say more privs.txt. So more allows me to just hit enter and go through these results like what I'm doing right now. Did this actually run or? What happened here? Okay, so we do have results, more just, I mean, this is a big file, I guess. We do have some results. So these results here are here for us to analyze and really pay attention to. So I'm going through them kind of fast here, but you kind of have to go through these two, go through the system and look for anything that might be interesting for us. So like we already found the DB user for WordPress. Let me look for CVEs. These are the easiest wins, right? Give me every instance where you saw a CVE show up. Of course, you saw my temp folder. You saw my temp folder. It's like, yeah, we see 4034 here. But if you look at the CVEs that was caught from that file, is this CVE 4034 from my temp. Let me show you the original entry. All right, right here. This is what you need. It says, hey, we found that in user bin pkexec, we can run that binary and it's tied to this privilege escalation. That's how you identify the privilege escalation tactic that we're using. There is another one, by the way. This is not the intended way, I don't think, but this is how I found out how to break into this machine. My two, in this case, Linpeas, told me, hey, have you tried this CVE here? So the logical thing is to copy that CVE number, go to your Google browser, and just start reading. You can read from NIST. What I like to do is I like to go to GitHub. It says local privilege escalation. So that looks interesting. Here is a POC from GitHub. It even has a video for it. You can watch the video and it will show you. Okay, so I just need to go to my CVE, run GCC, compile the CVE, and run it. It's very simple. All right, if you go around as well, you will notice we have another one from GitHub. Just showing you a couple more options here. This one here says exploit.sh. It's a proof of concept. Same thing, they give you a video. So before we run this, let's just look at our bash script. It runs setup.e, where it creates this directory here. Then you create a fake exe, give it permissions. All right. But it's the same thing. We have to compile the C code for this one and then run it. All right. So what we do here, we just clone this. We can clone this to our Kali Linux, or we can clone it to the victim. Doesn't really matter. If the victim does not have Git, then you have to clone it on your Kali. So, so I'm going to go to this blank directory and say git clone on the victim. I'll clone that repo. Our ls CVE-2021-4034. All right. All right, so all we need to do is run this. If I do an ls -l, I bet it's an executable already. Yeah, So all we need to do is run this. But before we run this to escalate our privileges, this is what we came here for today. Let's check our security onion. Do we have an alert that is telling us that privilege escalation using the polkit happened? And if we do, we would like to know about it. All right, so if we refresh this, not that. All right, we're looking in the last hour. Look how clean this is. I'd like you to pay attention to the alerts that we have right now, because when I come back, I'm just going to refresh this page. Now, expl.sh. Then I'll show you what the detection looks like. So this one is going to print pond, and if I say ID, I'm now root. Who am I? I'm root, cd/root, ls. I bet here is the flag. All right, we got a root flag. Whatever. Now I'm just interested. Did I detect the PwnKit when you ran this funny exploit here? Let's go back to security onion. Let's do a refresh. Pay attention to this last here. Possible attempt to exploit local privilege escalation vulnerability in polkit, pkexec, right there. So we did detect our privilege escalation. And the main goal here is, okay, there's one, right? Let's do it a couple times so we can generate 3. If I exit, because I want to make sure that we are actually generating the expl.sh. We're generating the same one. I'll exit again. Maybe one more time. So we should have 4 or 5 alerts. Then I'll show you the rule that detected it and how it detected it, which is really, really helpful. Okay, so right now we had 1 on the count. Let's refresh and see if the number goes up. It should go up by at least 2 or 3 since we ran it multiple times. And that's because host-based intrusion detection is running on that system. All right, I don't know why it only ran once. No, wait a second. Of course, it ran as many times as I was looking at this. So here it is, 4 times. We ran it multiple times. Your mind should be like, well, what the hell just happened? How did we detect that? How do we detect things? Because running an exploit from the internet, great. Being able to detect it, that's another story. And let's go through that right now. It's a high severity, so everybody gets woken up here. Your boss is sleeping. Your boss is firing fireworks for 4th of July. This alert is firing. If this is happening on 15, 20 servers, you are in a lot of trouble. Somebody has to come back, kind of hungover and stuff, to come and look at this. Okay, so the log here that we saw said the value for the shell variable was not found in this. So that's a common indicator of compromise for this privilege escalation that you will see when it happens. Every time you run that script that I did there, sometimes you get this, the value for the shell variable was not found in etc shells. That's just how it works. When you try to use that to escalate your privileges, you get that message. This log here is significant because when you go to look at our rule that we are triggering it with, we need to know this is what we're looking for. Where did we find this log? We found it in var log auth.log. This is from the actual host itself. The actual computer is telling us, hey, the value of the shell variable is not found. So it's var log auth.log. Let's go find out. We should be able to go to the system and get that file. So this is on the actual victim system. Look what we got. The value for the shell variable was not found. So you need to see the pieces for the rule to be able to see. So we saw the message on our intrusion detection system. It's saying it triggered an alert. We see the message on the actual host. It says, this is what we have. So we get an error every time we run that privilege escalation. What does that inform for defenders? Defenders are like, okay, so if somebody's trying to do the polkit CVE vulnerability, it's going to generate this error most of the time. So what should we do? We put this in the rule. That brings us to our intrusion detection system. By the way, right now, as you can see, I reloaded my wazuh manager, but I am on my security onion intrusion detection system. This is what we're using for host-based intrusion detection system. I'm in my wazuh shared default folder. This is where we define some detection, but I don't think this is where I should be. I would like to be in the rules folder. So let's use 80. For host intrusion detection system. So in the OPT security onion rules host intrusion detection system, this is where we defined how do we want to actually detect this. If you're creating your own rules, you can put them in the local.rule set. So let's use nano. Local. What? There's no nano there? There it is. All right, so here's where we define the rules. So if you want to do detection, this will not work out of the box. We need a rule. Please pay attention with me here. I hope you've been paying attention. If you want to define rules for local, you put them in this file here, and you say, hey, by the way, this is a syslog rule. That's what the group name is. You can name it whatever you want. It doesn't really matter. The rule ID, I just gave it a random number. I generated this number myself. For level 12, that means it's a very high severity rule. So that's what you can do. Then the program name, we're looking for pkexec. What are we looking for? We are looking for the value for the shell variable was not found. It's word by word, which is ridiculous, right? Word by word, the full sentence. This is on our intrusion detection system. We're like, hey, intrusion detection system. If you see this from syslog, from the victim, generate a high severity rule. The value for the shell variable was not found in that location. Or where are we getting this? We're getting it from, in this case, right here on the actual victim. So the defenders were able to find out, oh yeah, this is what they generate when that payload is ran. We're going to put that exact word all the way up to here. I think this is a lazy rule, to be honest. I think rules that just look for a very specific string, they can be valuable in the heat of the moment, but the rules need to be more intelligent than this. Because if I were running this script and I can modify the log files, this will not even fire. But for now, this is what we have. So this is the rule. These are the wazuh agent rules. If you wanted to make sure that your rule worked, I'm giving you a trick here. You need to do this. On your security onion, please run this. Sometimes you have the wrong syntax. You need to run sudo docker exec wazuh agent and run the log test command. If you don't run this, you will not know whether or not your rule is healthy or not. So let me show you what that looks like. If I do 161, it should be a clean pass where you don't get any errors after this. And then once you run that, you should be able to just say, oh, I got a log file. I think this is what we're looking for. Then you can paste whatever logs you want here to see if they match any of your rules. In this case, of course, I'm missing something. It didn't match. It will match something. But for now, we'll just quit. If you have any questions, please let me know in the chat. But I think by showing you that we can detect intrusion detection system using our intrusion detection system when people are trying to do privilege escalation, you learned something here. I know this is a lot of dense information and not everyone is able to follow every step, but the goal here is really to show you that it's possible for us to educate ourselves on what we are doing, how that shows up on the wire, or how intrusion detection would work. This will make you a very good defender, I would think, because when you see alerts firing, not only do you know how they're fired, where they came from, how the rule that is actually waking you up at night was created, or the rule that was assigned to you was created, but you just get a holistic view of things. So that's what we had here. We fired it 4 times. They're all identical. There isn't really much we can do here than, yeah, it's the same. It's looking for the value from the log file. If you have any questions, please let me know in the comments. But right now, I'm just going to do the classic postmortem. If you go to Kibana, you can say agent name for beloved. In the last hour, what did we find? Web access log. This is going to show us a bunch of all those. I like Kibana a lot because then it actually shows us, the data in its raw format, which it doesn't get better than this. We got our reverse shell on port 666. So why not just get our port and see what our reverse shell looked like? If you need help setting up this lab, please let me know. I'm planning on setting up sessions on Fridays to just go through the lab setup in the back end and help people make sure that things work. All right, so 666 is not really helping me. Give me that one, the destination port of 666. All right, so these are the instances where we saw the destination port of 666. Yes, suricata. Oh, suricata was complaining about that port? What? What did suricata want? Let's check it out. It's a medium alert. Of course. Suricata didn't like us running the command ID. If you get into a system as an attacker, if you type who am I or ID, suricata will really like to report that to the defenders. That's what happened here. So it saw the content for UID of ID. All right. But this is when we got our reverse shell. And then let's look at Zeek. Zeek is just, a gate person who's just, I saw this, I saw that. They're just like telling you transactions. Like, hey, I saw traffic coming through on this port. Yeah, so it's up to you to really make sense. We generated a bunch of weird traffic. I don't like that. Weird usually means that there was some funny business happening with my traffic. But we have a con.log here. This one was actually established, which is good. So this is our reverse shell here. If you're curious, like, hey, how does a reverse shell look like on the wire when traffic is not encrypted? There you go. You can see it in the connection logs in Zeek. You can request pkep and see who done it. But today we're not going to request pkep. Just wanted to show you what that looks like. All right, this was a lot of fun. I hope you enjoyed it. And if you like, please set up your lab. There's a playlist on this channel on how to set up your own Security Onion lab. You can set it up on a simple $300 Dell server. In the back here, I actually have a Dell server that I have an 820. I ended up spending more money on this 820 because it's quiet. You can't even hear it right now, but it's back there. But you can pick any server from eBay for like $100 or so, set up your ESXi and be able to follow along, and you will learn a lot. I don't plan on even stopping doing this anytime soon. This lab has made me a better person both at work and even at home. It has instilled a lot of confidence in me, in my abilities to actually do my work, because I can read this traffic in no time. And I wasn't like this when I started. I told you at the beginning, I'm self-taught. I did not go to get a master's in this stuff. I had to learn it in my own home lab. And because of that, it's something that I think that maybe you should set up yourself as well. And like I said earlier, for those who need help setting it up, in the coming weeks, Fridays will be our lab setup days. We can all hang out. It will not be live streamed. It will just be a simple Zoom call for an hour, and we just chill and learn, and people can set up their own labs. So that's it. All right, let's see. How anonymity will provide when we use C2 server instead of Netcat? Most C2 servers in this instance, that's a very good question. If you use a C2 server, most C2 servers that I've seen, they actually would encrypt the traffic. So they would, you will not see traffic in real, in plain text. So they would kind of help in a little bit, but you still get detected. Especially host-based detection that I showed you today will still work regardless. You will be detected with the privilege escalation that I showed you today. But as far as network traffic moving across the wire, most default C2 servers will actually have it by default encrypted using SSL. So that's what we have there. For messaging me, there's an email that you can use. I'll be posting in our community channel for our lab setup sessions. So for those who want that, please subscribe and just keep an eye on the community channel. I'll be posting live Zoom links in there. I'll probably post on Thursday, letting you know that on Friday, around 9 p.m. same time, we'll start a quick Zoom call. All I ask is that in your Zoom call, you should have your YouTube name there so that I can boot out trolls in my Zoom session. So if you use a different name on your Zoom, on your YouTube, make sure that that matches your Zoom session. Otherwise, we end up with people who might start doing funny business in my live streams. I don't want that. All right. I think that was it. And hey, Mark, thanks for joining us tonight. The first time seeing your picture, and I hope you enjoyed some of this stuff, and you can join us next week. Otherwise, but December, Matthew, BT, and everybody who was here, thank you all for being here, and I hope to see you next week or on our Friday sessions. Thanks, and have a good one.